Welcome to Vision Plus and welcome back to this senior form mathematics and complex numbers. We are now doing example 3 under the polar form of the complex number. Example 3 says that we are given these complex numbers and that we need to convert them into the modulus argument form. The modulus argument form is the same as the polar form of the complex number. So the solution is, for part A, we are given 3 out of 7 plus 2i. So the solution, we say that let any letter which is a complex number z be equals to 3 out of 7 plus 2i. After this, we need to find the magnitude of the complex number r, and then we find the argument of the complex number theta, and then we substitute them and we get the modulus argument form. So the magnitude of the complex number r is given by the square root of x. X is the real part of the complex number 3 out of 7 squared plus y. Y is the coefficient of I, which is 2 squared. And then you press your calculator. 3 divided by 7 squared plus 2 squared. I'm getting 4.1838. Let me press again. 3 divided by 7 squared plus 4. Yes. And then you find the square root of this value. Square root of 4.1838. I'm getting 2.0454 units. So this is the value of r. Now let's go on to find the angle that the complex number makes with the positive x-axis, which is the argument, and then we get the polar form. This is the real axis of the complex number z. This is the imaginary axis of the complex number z. And then you come, we have on the real part, we have 3 out of 7. This is the origin. Let me put here 3 out of 7. Then correspondingly, negative 3 out of 7. And then 2. 2 is bigger than 3 out of 7. Why? 3 out of 7 is 0 point something. 3 out of 7 is 0.4. So we are going to make 2 kind of far away from the origin, from the center 0, 0. But there is no problem. Even if you put 2 closer here, there is no problem. But we just need to apply rationality. Now, from here, 3 out of 7 is on the real part, positive, which is here. 2 is on the imaginary part, which is there. So we are going to look for the point of intersection of these two complex numbers. They are meeting somewhere there. So we draw a straight line using a ruler from the origin up to where the complex number is, and then you put an arrow on top. This is your complex number. You have called it Z. Now, the argument is this angle that the complex number will make with the positive x-axis or the positive real axis. And from here, you go on and extract the triangle as we did when we were doing the argument. But for this case, I'm not going to do it. It will take our time, and you know it anyway. So from the origin up here is 2. That means from here up to the tip there is also 2. From the origin up to here is 3 out of 7. That means this distance is also 3 out of 7 after extracting the triangle. Now, we are going to apply any trig property, any trig identity, either sine, cosine, or tan. So I'm going to use tan because they all give the same answer. So I'm going to say tan of our angle theta is going to be opposite to the angle is 2 out of adjacent is 3 out of 7. Then here we're going to have what is 2 divided by 3 out of 7. it is the same as 14 out of 3. Simply because you know that 2 divided by 3 out of 7 is the same as 2 times 7 out of 3. 7 times 2 is 14 out of 3. And then from here we now say our angle theta becomes the tan inverse of 14 out of 3. And then we press the calculator here. 14 divided by 3, tan inverse of the angle. Tan inverse of the answer is 77.91. 77.91 degrees. So this is the angle which the complex number makes with the positive real axis or x-axis. And if we look at it, it is in our range. So this qualifies to be the principal argument. But it doesn't matter whether it is a principal argument or not. So from here, after getting an angle, then you come and substitute. Because you know that z is given as r into cosine of theta plus I sine of theta. This is the modulus argument form of the complex number or the polar form. And then we substitute here. What is the value of r? The value of r is 2.0454. So 54 into cosine of our angle, which is 77.91 degrees, plus I, don't forget this I sine of the same angle, 77.91 degrees. And that is the answer in the polar form. Or alternatively, you can use the other form, which is also the modulus form, where z is given by r, theta, where r is the modulus of the complex number 2.0454, theta is the angle or the argument of the complex number, which is 77.19 degrees or 91 degrees. So this is the solution to part A. Let us go to part B.